So what x value are we looking at? Each one of these things, f of what? 2 equals 3. F prime of 2 equals -1. And f double prime of 2 equals -1/2. All right? So they're telling us information about the original function, the first derivative, and the second derivative at x equals 2, which means x equals 2 is probably a key point or a key focus of what we're doing in this problem. There are 3 parts to this problem. Part 1 says, find the equation of a tangent line to f of x at x equals 2. Amazing. There are 2 things I need to write the equation of a tangent line. Who can tell me the 2 things I need? A slope and a point. All right. So if I'm looking for the slope of a tangent line, m of a tangent line, what is the slope of a tangent line? Good. It's the first derivative. The slope of a tangent line is the first derivative. And so looking up here at what's given to us in this problem, what is the first derivative equal to at 2? -1. It says f prime of 2 equals -1. The first derivative at x equals 2 is equal to -1, which means that the slope of my tangent line at x equals 2 is equal to -1. All right, and then I also need a point. I know that my x value is 2. What's the y coordinate on my original function when x equals 2? What is it? 3. Beautiful, and I can find that from right here. The y coordinate on my original function is equal to 3. So I have 2, 3. So using those 2 things, I can write the equation of a line using what formula? Point slope. So y minus y1 equals m times x minus x1. Question, can I leave my answer like that? Absolutely. Guess what? If you get this wrong, like if you decide, hey, I don't like leaving my answer in point slope form, it makes me more comfortable to write my answer in slope intercept form, and you go and convert it into slope intercept form and you do it wrong, you get the problem wrong. If you leave your answer like this in point slope form and you get it right, you get the problem right. So throw out the window the notion that you need to write it in a certain form and be okay with leaving it like this, because you will get the problem correct more often than if you try to convert it into slope intercept form. All right, beautiful. That's part A. Questions about part A? Okay, let's look at part B. Part B says, use the tangent line to approximate f of 1.9. All right, use the tangent line to approximate f of 1.9. So here's the thing. I don't know what my function looks like. Do you know what my function looks like? No, I don't think anybody out there knows what my function looks like, because they don't tell us anything about the function except for the point, the first derivative, and the second derivative. So I don't know what my function looks like, but let's just say that maybe it looks like this. All right, so here's 2, and that's this point right here on the graph, okay? Let's just say it looks like that. And there's my tangent line. If I want to use that tangent line to approximate f of 1.9, 1.9 is like right here. Are we okay with that? So here's what this approximation is helping us with. I know that I can't figure out exactly what 1.9 is, but if I use this tangent line, if I get really, really, really close to 2, then the tangent line can help me figure out approximately what it would be equal to on the original function. It won't be perfect, but it'll be close enough to the point where it will help me to approximate it. So, any ideas on how we can approximate f of 1.9 using the equation of the tangent line? Say it again. Plug it in. Yep, plug it in. If you want to approximate f of 1.9 using the equation of the tangent line, plug in 1.9. Now, you are not allowed to use a calculator for this. This is another reason I suggest leaving it in point slope form, because it will be much easier to solve this if you leave it in point slope form. What is 1.9 minus 2? Negative 0.1. So this is y minus 3 equals -1 times negative 0.1. Next question. What is -1 times negative 0.1? Positive 0.1. So this is y minus 3 equals positive 0.1. And to solve for y, or in other words, to isolate y, how do I get rid of that -3? Add it to the other side. So what is 0.1 plus 3? 3.1. Beautiful. And that is my answer for part B. Y equals 3.1. So using the tangent line to approximate what 1.9 would be, it's approximately equal to 3.1. Again, it's not perfect, but it's approximate. The closer and closer and closer that x value gets to 2, the more and more accurate it would actually become. All right, are you ready for this last part? This last part is a conceptual problem. It says, does the tangent line give an over or under approximation of the actual value of 1.9? And justify your answer. The easiest way to do this is to actually visualize what it looks like. So we need to interpret what this information means. So looking back up here, if f prime of 2, in other words, the derivative at 2, equals a negative value, if the derivative is negative, what does that tell me about my original function? It's decreasing. And if the second derivative at 2 is negative 1/2, I'm sorry, so the second derivative is also negative, what does that tell me about my original function? It's concave down. On your paper, can you draw a picture of a little image that's decreasing and concave down? And let's just say that this is x equals 2. Do you guys agree that that x value is on a point of the graph that's decreasing and concave down? All right, draw a tangent line at that point. Here's how to figure out if the approximation is over or under. Is the tangent line above the graph or below the graph? Above the graph. Then the tangent line is an approximation that's an overestimation. If it's above the graph, it's an overestimation. If the tangent line is below the graph, it's an underestimation. So if you guys look closely enough, I'll try and draw it right here. Let's pretend that that blue dot is what we figured out that f of 1.9 is, and this green dot is what the actual value of f of 1.9 is. Oh, you guys can't even probably see the difference. Here's the blue one on top, and this is a green down here on the bottom. I know they're kind of similar in color. But ours is an overestimation, meaning that it's just a little bit above what it should be. So we're just going to write that it's an overestimation. And here's how we can justify that. We can justify that it's an overestimation because we know that the function is decreasing and concave down. Therefore, the tangent line lies above the curve. So write that down on your paper as well. This function is decreasing and concave down at x equals 2. Therefore, the tangent line lies above the curve.